Okay, YouTube, in this video we're going to focus on what we refer to as the identity matrix. And so when we talk about number systems, let's say the real number system, we often have identity elements under certain operations. That would be things like if I were to take, let's not do capital A, if I did a real number A times the number 1, I would get the number A back, or under the operation of addition, if I did a real number A plus, say, the number 0, I would get the number A back. So these two elements here, the multiplication by 1 and addition by 0, when it comes to real numbers, are what we refer to as identity elements. These are identity elements. And identity elements are elements that under a specific operation, if we were to take some non-identity element, say with that operation that we're talking about, in this case multiplication, and with that identity element, you would get back what you started with, essentially. So the question here is this: is there a multiplicative or a matrix here that we can multiply by? But multiplicative identity for matrices. Can we think of a matrix that when I take it times A, I really just get back with A again? And so we do actually have this matrix here, and we refer to it as this matrix I. And so the nice thing about I is that I is the identity matrix. Okay, so identity matrix. And it is the matrix that when we multiply any matrix by this identity matrix, we get the same matrix we started with back again. So let's go ahead and define an identity matrix. We say a square matrix that is n by n, has as many rows as it has columns, that consists of ones on its main diagonal and zeros everywhere else, is called the identity matrix of order n. So in this particular case, this is an example here. You notice this is the letter I, capital I, and we often write just I3. There's really no need to write I3 by 3, but by writing I3, we really truly imply that, hey, this is a square matrix that is the identity matrix of order 3. So we say this is our 3 by 3 identity matrix. If we were to write, say, I2, just as an example, we would write the matrix that has ones down its main diagonal and zeros elsewhere. So I4, I5, I6, da 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 da. Basically, the identity matrix is this matrix that's populated with ones down the main diagonal and zeros elsewhere, and it's always a square matrix. So as I mentioned before, that this identity matrix under the operation of multiplication, it is the one matrix that when we multiply something by, we get the same matrix back we started with. So the note here to mention is that if we take the identity times A, we just get A. And this is really important. You might say, well, these say the same thing, but remember, order matters when you multiply. So if we take A times the identity and switch that order around, you still get A. So what I want to do in this example is just kind of demonstrate this here. So what I did was I got my calculator out and I put in, let me see, turn on. I put in a matrix A here, on, enter, on. Well, that doesn't seem to want to be working here, so we'll quit out of it and we'll turn this back on. You know what, this actually plays into what I need to do anyways. We'll just make up a 2 by 2 here. So let's call this our matrix A, and how about 1, 2, negative 3, and 1? You know, this is just as good as any other matrix. What I want to do is I want to multiply this by the identity matrix of order 2. So we're going to take this 2 by 2 here times this identity of order 2, where we have ones down the main diagonal and zeros elsewhere. And what I want to prove is that we get A. So we say A times I. What we're going to do is write these side by side, and we'll do our matrix multiplication here. So what I know is, in terms of matrix multiplication, I can only do this if the inner dimensions match on my two matrices here. So we have a 2 by 2 times a 2 by 2, and I notice that these inner dimensions do indeed match. And so because they match, we're going to get a new matrix that has the outer dimensions as its order. So we would say that this is a new 2 by 2 matrix, and we're going to get each of these entries right here. So what you'll notice is this. To get our first row, first column entry here, we're going to have to take our first row times our first column here. We'll do that multiply and add deal. So we say 1 times 1 is 1 plus 2 times 0. Now we'll move over 1 and down 1. 2 times 0 is 0. If we move over here to our first row second column, we will take our first row times our second column, and what you'll notice here is you take 1 times 0 first, and then you add that to 2 times 1. In other words, we get 1 times 0 is 0 plus 2 times 1 is 2. In this particular case, we'll take our second row times our first column to get our second row first column. We get negative 3 times a positive 1. It's a negative 3 plus, now we'll move over 1 to the 1 and down 1 to the 0. 1 times 0 is 0. And then last but not least, we'll take our second row, second column here. We get negative 3 times 0, which is 0, plus now move over, move down, we get 1 times 1 is 1. So in other words, we get this new matrix here that comes out to be this matrix 1, 2, negative 3, and 1. So I want everybody to see that we got back what we started with. And what I would encourage you to do now is write this on your paper. I want you to carry out 1001 times the matrix 1, 2, negative 3, 1, and prove again that you do indeed end up with this matrix right here. So when I said this plays in well with what we need to do, let me go ahead and change my contrast here on my calculator. But we're going to go into our matrix menu. What I want to do is I want to show you just really quickly here how you would pull out an identity on your calculator or your TI. So we'd go into our matrix menu. And the first thing I'm going to do is I'm going to edit matrix A, and I'm going to type in this matrix here, 1, 2, negative 3, 1. So this is a 2 by 2, and we have 1, 2, negative 3, and 1. And the other matrix here, I'll go back into my matrix menu and I'll go down to edit B. And we'll type in a 2 by 2 also, 2 by 2. And this 2 by 2 is 1, 0, 0, 1. And so now if I were to quit out of this and I say, you know what, quit, sorry. We take matrix A now, matrix A, times matrix B. We can just go ahead and write matrix B. What we'll get is this original matrix. And if we were to rewrite this now and do matrix B times matrix A, what you would see is we still indeed get this. So the identity matrix is just the square matrix with ones down the main diagonal and zeros elsewhere that has the property that when we multiply any matrix by that thing, it stays the same. Cheers.